Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing Illustrative Math, Grade 8, Unit 7, Lesson Number 1, Practice Problems. Our first question here says, write each expression using an exponent. So, we've got 1 times 7 times 7 times 7 times 7 times 7, which is equal to 7 to the power of, how many times we multiply 7 by itself? 1, 2, 3, 4, 5. 7 to the power of 5. Now, we've got 1 times 4 fifths times 4 fifths times 4 fifths times 4 fifths times 4 fifths. This is 4 fifths. To the power of, how many times we do that? 1, 2, 3, 4, 5. Now, we got 9.3 times itself a whole bunch of times. That will be equal to 9.3 to the power of, how many we got? 1, 2, 3, 4, 5, 6, 7, 8. 9.3 to the power of 8. The number of coins Jada will have on the 8th day if Jada starts with 1 coin and the number of coins doubles every day. So, 2 coins on the first day of doubling. 2 coins. How many days are we doubling it? 8th day. 8 times 2 to the power of 8. Evaluate each expression. 2 to the power of 5, which means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 of them. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 3 to the power of 3 is 3 times 3, which is 9 times 3, which is 27. 4 to the power of 3. 4 times 4 is 16. Times 4 is 48. 6 squared. 6 times 6 is 36. 1/2 to the power of 4. We can also think of this as 1 to the power of 4 over 2 to the power of 4. 1 times 1 times 1 times 1. Doesn't even matter how many times we do it, it's always going to be 1. 2 to the power of 4. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. One third to the power of 2. 1 squared is 1. 3 squared is 9. Claire made $160 babysitting last summer. She put the money in a savings account that pays 3% interest per year. If Claire doesn't touch the money in her account, she can find the amount she'll have the next year by multiplying the current amount by 1.03. 1 for the original amount and an extra 0.03 for the extra 3% interest she gets. How much money will Claire have in her account? So, after 0 years at the beginning, let me make a nice little table. 0 years, she starts out with 160. After 1 year, she has 160 times 1.03. 164.8. 164.8. After 2 years, 164.8 times 1.03 is 169 0.744, 169.74. How much money will Claire have in her account after 5 years? So we can continue our table here. 3 years, 169.744 it was, times 1.03, 174.84, 174.84. Just to make it look like we're continuing. 4 years, and we want 5 years. 174.84 times 1.03 is 180. I should have looked more closely at the cents. 174.84 times 1.03. So 0.09. And then 180.09 times 1.03, 185.49. 185.49. Now, we also could have done this slightly differently. Every time we multiplied this by 1.03, if it were a huge number of years, like, ooh, look, the next question, after 30 years, do you want to do this 30 times? I don't. I'm kind of a lazy bum. That's why I'm a math teacher. If we are multiplying by 1.03, how many times did we do that? 1, 2, 3, 4, 5 times for 5 years. What does it mean when we multiply something by itself? Well, that's an exponent. We could just multiply by 1.03 to the power of 5 times our original amount, which was 160. Let's skip all the intermediate steps and see what the computer tells us. 1.03 to the power of 5 times 160. 185.40. Hey! That's what we got, with the exception of a little bit of rounding, but we rounded on a few of those. That sure saved us some steps. Write an expression for the amount of money Claire would have after 30 years if she never withdraws any money. Well, she had $160 times 1.03 to the power of, how many times are we doing it? 30. This just says write an expression, but let's actually calculate what that is. 1.03 to the power of 30 times 160. Did I type that in wrong? 1.03 to the power of 30 times 160. 388. 36. 388, 36. That's not too bad. 30 years, they've over doubled their money just by not spending it. Okay, what have we got next? The equation, y equals 5,280x, gives the number of feet y in x miles. What does the number 5,280 represent in this relationship? So it's the coefficient of x, it's the slope, but for this we have to think we have number of feet, number of miles. 5,280 in this is the number of feet per mile. Because if we multiply the number of miles by 5,280 to get the number of feet, that's the number of feet per mile. Okay, what's next? The points 2, 4, and 6, 7 lie on a line. So those 2 points are on a line. What is the slope of that line? Remember, slope is change in y over change in x. What's the change in y's? Well, we went from 4 to 7. From 4 to 7 is 3. We went from 2 to 6, which is 4. So what's our slope? 3 over 4. This diagram shows a pair of similar figures, one contained in the other. Name a point and a scale factor for a dilation that moves the larger figure to the smaller one. Okay, where does the center of dilation needs to be? The center of dilation is the point that does not move. Because it's the point that does not move, which point do both triangles share? Well, that's point A. Now, what is our scale factor? We go from the large to the small, which means we need a number between 0 and 1. If we make it bigger, it's a scale factor greater than 1. If we make it smaller, it's a scale factor between 0 and 1. Not negative. I know it's been a while since we've done these, but scale factors between 0 and 1, not negative. Now, how much did it change? Well, this distance was 3 and became 1. This distance was 1, 2, 3, 4, 6 and became 2. What do you multiply 6 by to become 2? What do you multiply 3 by to become 1? We want to dilate with a scale factor of 1/3, because 1/3 is what you do to turn 3 into 1 or 6 into 2. And centered at A. Center of dilation is point A. That is the last one here. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.